Okay, so we're going to work on doing some Gauss-Jordan elimination here. One thing to really clear up, okay, is that, our goal is to get a matrix, hopefully, that has the first bunch of rows being really the identity matrix. So, maybe it looks like something like that. That would be ideal, right? But the thing is, remember, those leading ones only have to be below and to the right. It doesn't have to be the next column to the right. And sometimes you can't get that. Maybe you might have, let me change this, 2, 0, 0, 1. Something like this, okay? The trick is you have a leading one. The next leading one, you just have to go down and to the right. It doesn't matter how far you go over, okay? And sometimes some matrices wind up doing that, especially the ones that have like infinitely many solutions. So you're not always going to get ones on the diagonal there. It's not always going to happen, okay? But that's usually what we shoot for, and then whatever happens, happens. Okay, so now let's say I want to use the Gauss-Jordan elimination. I'm going to get rid of these before I start using those numbers on accident, to solve this system equation. So, of course, the first thing is to write the augmented matrix. Okay? Now, I do not worry about the ones, not until the very, very end. Okay, but notice if I divided the first row by 2 to get a 1 in this top spot, okay, then I would have a bunch of fractions in here. I'd have a 3 halves, a 2, and a 5 halves. And now I'm going to start working with fractions. Well, I don't like doing that. It's not the most efficient way to do it. Okay, so what I do is I look at that entry and I go, okay, well, I need zeros below it. Okay, so my first goal then is to get rid of this 3. Okay, and I'm going to leave the top row alone. Okay, on this set of computations, and I'm going to take 2 times row 2 and subtract 3 times row 1. Now what I've done, I always take a row and multiply it by the entry in the other row. So I'm taking row 1 and multiplying it by that 3. And then I'm taking row 2 and I'm going to multiply it by the 2 that we found in row 1. I always multiply each row by the other row's entries. Okay, and then I can either add or subtract in order to get a 0. So I know I'm going to subtract here because 2 times 3 is 6, minus 3 times 2 would be 6. That gives me the 0. Now, it's easy to make mistakes. Don't always do all of this stuff in your head, and that's where I screw things up a lot, right? So maybe I want to take a moment, do 2 times 4 minus 3 times 3. If I can get this thing to right. Okay, and that's going to be 8 minus 9, so that's going to be a negative 1. Okay, and then I'm going to have 2 times negative 5 minus, 3 times negative 4. So that's a negative 10 plus 12 would be 2. Okay, and then 2 times negative 6 minus 3 times 5. Negative 12 minus 15 would be negative 27. And now I'm going to do the same thing with the next row. Now I never do more than 2 operations at a time, because if I do, I wind up getting myself a little bit confused, do something wrong. So now I want to get a 0 in this spot where the 4 is. So how do I do that? I'm going to do that with row 1 again. Okay, I'm going to take 4 times row 1 minus then 2 times row 3. Again, this 4 is coming from the 4 over here, and then of course the 2 is still the 2 that is up in row 1. So it's always the other entry times that row. All right, now 4 times row 1, so that's 4 times 2 minus 2 times row 3, and that gives me the 0, right? Okay. And then 4 times row 1 minus 2 times row 3. That's going to be, 12 minus 10. So that's going to be 2. Okay. And next one, 4 times negative 4 minus 2 times negative 6. So that's negative 16 plus 12, so that's negative 4. Okay. And I'm still trying to double check things as I go. Okay. And then 4 times row 1 minus 2 times row 3. So that is 20 minus 14, so we're going to get a 6 there. Now, one thing I do note here is this has actually turned out fairly nice for me, okay, in that if I multiply this row by a negative 1, I'll have a 1 in that spot. Okay, so I'm going to go ahead and do that. Okay, 2, 3, negative 4, 5. So I'm going to take row 2 times a negative 1. It's going to be 0, 1, negative 2, 27. And I also see that everything in this row is even. So I am also going to take 1/2 of row 3. Anytime I get a chance to divide by something and still wind up with integers, I do, just because I like working with the smaller numbers. Okay, that's the only reason. Okay. So now I've got zeros below that top left entry. Now I'm going to move to this, and I want zeros above it and below it. Okay. So on the top side, where I want to get rid of this 3 that I just so greatly marked out, hold on, I'm not going to be able to read it. I meant to highlight, not write over it. I can't read it if I write over it, right? So I'm going to take then 1 times row 1, just to emphasize, minus 3 times row 2. Okay. All right, so that's going to be 2, because we do 2 minus 0. 3 minus 3 times 1 would be 0. Okay. Negative 4 minus 3 times negative 2. So that's negative 4 plus 6. That'll be 2. Okay. And then 5 minus 3 times 27. So that's 81. So 5 minus 81 would be somewhere around negative 76. Okay. Right now, for the bottom row, I'm going to focus, I need 0 here. Okay. So I'm going to take then and just take row 3 minus row 1. Okay. So, and I'm leaving this row alone. So row 3 minus row 1, I'm going to get 0. Negative 2 minus negative 2 is 0 again. 3 minus 27 would be negative 24. Okay. And right off the bat, oh look, these are all even. So I am going to take that, and I'm going to take half of it. That's going to be 1, 0, 1, and half of that's going to be 1, negative 38. 0, 1, negative 2, 27. And this is the matrix we've wound up with so far. Okay. And what does that tell us then? So anyway, one of the things I do is I never worry about the ones until I get to the end. If any of them aren't ones, then I just divide that row, and I might have fractions at the end. Okay, but notice I did not worry about getting this to be a 1. Okay, not until the very last step. Okay, this turned out to be a 1 early on. Great, that worked out great. Okay, but it was a pure accident. Okay, that was not intentional. Okay, I don't intentionally get the 1s until the very, very end. So that way I can always do integer stuff. Okay, and I just think that's easier to type into calculators. It's easier for the mental math. And now I do have it in row reduced echelon form. Okay, to be a nice technicality, okay, I could take the row 3 and divide that by the negative 24 and get a 1 in that spot. So it's more obvious. Hey, look, that's row reduced echelon form. Okay. Every time I see a leading 1, okay, I go down to the right, and there's the next leading 1. I go down, and all the way over here to the right, there's the next leading 1. Okay, that's fine. It didn't wind up being on the diagonal, but that's cool. Now, to interpret this answer then, I always like to write my equations because it makes it a little more clear to me what's going on. This says x plus 0y plus 1z equals negative 38. We have 0 x's plus 1y minus 2z has to equal 27. Okay. This bottom one is just that 0 equals 1. Now this bottom row is a problem because 0 is never equal to 1. Okay. That indicates to me that we have no solution. Okay. This is an inconsistent system of equations. Okay. Because that bottom row is always going to be false. Okay. Now, if it turned out to be a whole row of zeros, that would tell me something different, right? So this question's done, okay? But just thinking about the interpretation of the answers and stuff, okay? Let's pretend for a second, okay, that I did all of this work, and at that bottom, I wound up with, instead of the 1, let's say I wound up with another 0. Okay? Then I would look at this and I would say, aha, x plus z equals the negative 38. Okay. Y minus 2z equals 27, and 0 equals 0. Well, you know, this is always true, isn't it? 0 equals 0. So my solution doesn't depend on anything from there. And we'll note now that the solutions in this case, every one of those has a z in it somewhere. So that tells me z is going to be a free variable. Okay? And I can let z be whatever I want. So we're going to let z equal t. And we do this a lot. It's just a game to reinforce the idea that we're letting z be whatever we want. Okay? So we parameterize it. Well, if that's the case, then x is negative 38 minus t, right? That's from this equation. I subtracted z from both sides. Now on the bottom one, that's going to be 27 plus 2t. So this tells me there's infinitely many solutions. All those solutions, this is negative 38 minus t for the first coordinate, okay, 27 plus 2t for the second coordinate, and t for the third. Okay, and we can pick t to be whatever we want. Okay, but the main focus was supposed to be just on the Gauss-Jordan elimination. And the main thing I really want to get through is that there's a lot of different ways to do it. And there's a lot of different right ways to do it. And maybe there's some more efficient ways than the way I just showed you. Okay? But as far as the calculations and stuff are concerned, in general, my strategy is to focus on the top left and getting zeros below it. Okay? So I want to get zeros here. And I don't worry about ones anywhere. Okay? So to do that, we multiply the second row times the entry from the first row and subtract the first row times the entry from the second row. Okay. Then when I go to do the last row, I play the same game. All right. Once I get zeros in those two spots, then I focus on these two spots and I do the same thing, get zeros there. Then I focus on these two spots, boxed in the wrong ones. The top two spots, get zeros there. Okay. Then, once you have those zeros, then go through and divide by whatever that leading entry is to get your ones. Okay? And that strategy will always work for you. It might not always be the most efficient, okay, but it is a strategy that will work 100% of the time. Okay, so hopefully that helps a little bit. Okay, and if you have any questions, please let me know.